All right, happy Friday and welcome to our WARDCam Advanced Topics webinar. We lead into a nice summer weekend. Hopefully you all have a good one. So gonna just review where we've got the other webinars stored. So if you go to our webpage, wardjet.com, and you go to the support area and down to support videos, got numerous videos there related to machine maintenance, but if we scroll down a bit more, then we'll see that we've got the other WARDCam videos. So we've got our WARDCam 101 webinar that did a couple months ago, and then shorter videos. This is the older advanced topics in WARDCam video that I did a couple years ago, so this will be a refresh on that. So got that there. So first of all, just want to review how to update WARDCam. Let me just close a couple of these things here. I'll close that one here. All right. So if you want to update WARDCam, you can go to the Help menu, and then if you go to About WARDCam, brings up this menu, and you can click on WARDCam Sites, and that'll bring you to this wiki page here. And here we've got the WARDCam section where you can download the latest version of the Midnight WARDCam. So just click on that quick download and pretty quick installation. When you go to, if you are updating and you go to post your first file, if you get any sort of error messages, give me a call because there might be a variables file that needs to be updated to match some of the new things that we've added into the variables area. So we've got that there. And one thing to also know is when you do a update, we will there's always a backup file that's created, and that's under the C drive under WARDJet. Sorry, C program data, and then scroll down to WARDJet. And then from there you go under WARDCam. And then here we have a backups subdirectory. So if you go into there, you'll see backups from any updates that you have done, and then the files that get backed up. So it'll just back up any files that get changed there. So that's where those files are located in case you ever need those. And then just want to review the functionality of the scroll lock key. So as you may or may not know, if you press the scroll lock key on your keyboard, there's a couple extra menus that'll show up. So if you don't have a physical scroll lock key on your hard keyboard, you can bring up your on-screen keyboard, press scroll lock, and then when that happens, there's a couple different menus that show up. So under the database area, you can then get to this global settings menu. So we'll go in here, a couple things I want to show you in here. So pretty much all these parameters up top, you should never have to adjust. And then as you scroll down here, you have this machine database file, material database file location. So normally if there's just one user using WARDCam, people will just point to this default location for their machine and material databases. If you have multiple people programming WARDCam, you might want everybody working off of the same machine and material databases so you don't get divergent materials and things like that. So if you want to, you can point to a network location that everybody can point to and then be working off the same information. If one thing gets changed, then everybody's working off that same change. Some people like that, some people don't, but you do have the choice of that. So if you did want to point to a network location, say for your material files, you can just click on choose file, and then you would go to wherever on your network that you have that saved, and then you'd choose that, and then that would go in there. So if I go into, for example, my WARDCam setup files here, I think I've got something here, I could point to that. And so now for the material files, it'll look in that location there. So the other thing that you can access, and I'm just going to change that back before I forget, so I don't totally confuse myself next time I use this. So I'll go program data, again, WARDJet, WARDCam, data, and material database is normally by default where it is. So the other thing that you can access with the scroll lock key turned on is the variables file, which I'll be showing you here in a little bit. And then The other thing is we do have a shape library, and we've added some additional shapes to this. So if you do download the latest version, there'll be some additional shapes in here, dog bone shape, and shapes that you can tell it how many sides that you want to have and things like that. The anagon, you can tell it how many sides you want, and circumscribed, inscribed circles and things like that. So we can add additional files to the shape library. If you want, you can contact me and I can help you do that, or I would do that for you. If you wanted to do it yourself, that is another thing that's fairly easy to do if you have any comfort level with doing any sort of programming. So in the shape library folder, click on that and brings you, of course, normally it would be here under, shape definitions. And here's all the files that we've currently got in there. And these are all basic XML files that you can take a look at and kind of get an idea how they work. I could do an entire webinar on just how to do that if everybody's interested in that. So the other thing that we can do here is you can set up, if you have different machines, you can, and the machines behave differently, you can set it up so each of them points at a different, we call variables file, which has the different ways that the machines behave. So I'll just pick a simple part for right now, and I click on this. So right now I've got my abrasive machine selected, 1030 nozzle combination. And if I go into my machine database, I've got a whole bunch of different machines in here. And you'll see in this post variable area that some of these are pointing to different locations. Our default variables file is this variables.py file. If I go down to one of my water only machines, I've got these ones pointing to a variables water only.py file. Because you might want to have a different delay, for example, after water off with an abrasive machine than a water only machine if you have multiple machines at your facility. And so by setting up multiple variables file, you can kind of fine tune the characteristics of each machine and not have to remember to change things each time that you switch from say an abrasive machine to a water only machine. So if we click on choose file, that again would be a file like this. So I've got the default post logic file that I'm using for my abrasive machines, and then I've got one set up for water only machines. And so you can have multiple variables files depending on the behavior of the machine. So if I just go ahead and do this as a abrasive machine for right now, and we'll just do aluminum, that's fine. Click on auto. So since I have that scroll lock key turned on, if I go into options, edit variables, it'll show me all of the tabs that are available and all of the options that are available on each of these tabs. If all of the options on a tab are turned off, which is this little eyeball here, so that means that all these options here are turned off. If there's ones that are not turned off, they show up in the light blue. If all of the options are turned off on a tab, then that tab will no longer be visible when you turn off your scroll lock key. So if this is a 2D machine and I don't care about my 5-axis tab, I can turn off all of these. And then when I save and exit and when I turn off my scroll lock key, and then I go back in here, then that 5-axis tab is gone. And it can also do the same thing for individual parameters if you don't want people getting in and potentially messing up certain parameters. So that's what the little eyeball here controls if you want to show a certain parameter. So for example, on my Waterjet tab, if I scroll down, I've got, say, dwell after water off, which on this machine I can have set to 0.25, and then on my water only machine I could have it set to 0.1, and then because I'm pointing to the different variables files, each one will just pull from the appropriate file for that value there. So we'll come back and talk some more about some other things in there in a bit here. So one thing that I wanted to talk about was circular piercing. So if I'm doing a part like this out of thicker material, let's say I'm going to do this out of inch-thick aluminum, and I want to make sure that I have enough time for the lead to pierce and get through the material before it gets to the edge of the part. If we go into our material database, and I'm actually going to say, let's do this out of 4-inch thick aluminum just to make it a little bit more dramatic. And we'll say we're doing 4-inch. So if I put a new thickness in here, click on calculate, it'll recalculate the feed rates based on the thickness and the machinability. And given how thick this is, you'd probably want to do a circular lead in, lead out, where it's going to sit there and make some circles. Hopefully you have enough time to pierce through before it starts and gets into the part. So with the advanced button turned on, over on the other tab, we have the circular lead turn. So that's how many circles it's going to make when it's doing that circular pierce. And then you can also tell it the diameter of that circular pierce to make as it's doing that. So normally we'll leave that the same, but you might adjust this depending on actually how many turns you have to make. So if we go ahead and do this, and let me switch to my new thickness of material that I've got here, and I'll just click on auto, hit this, create my CNC file so we can take a look at it. So up here, we've got the circles that we're making for the that circular pierce. So it does basically half circles. So each of these would be one time around. So you got 1, 2, 3, and then there's a parameter in the variables file where you can tell it to make an extra turn or however many extra turns you want. So that's why there's actually 4 turns on this circle here. And then up here, we've got the feed rate. Now, if this is not enough circles, your inclination, of course, is going to be, and let me point out what that feed rate is. So the feed rate right now, just 0.57 inches per minute. So if that's not enough circles, we can of course go back into the material database and change the number of circles. So I come in here and say, all right, I need to actually make, I think 20 circles because it's so thick, and save and exit, and I'll make that CNC file again. And we'll just overwrite what we had there. And so this is going to reload here in a moment. So right now it's 0.5726 for the feed rates. We got our 4 circles, hit OK. So feed rate changes, but we don't get the additional circles. So that's a little bit of a head scratcher why that happened. So basically what you have to do if you do change that number of circles to get it to actually recognize that, you've got 2 options. You can go back to your parts screen and you can just choose a different machine for a moment and then go back to whatever machine you had. And then that will basically reset everything in WARDCam's toolpath memory there. And then when I make my CNC file again, we'll see that we've got the extra circles that we had asked for. So there's the old one, refresh it. Now we've got all of our extra circles. And then, of course, as we do more circles, WARDCam is going to want to increase the feed rate that it does those circles on, just because that's the way it was written. Now you might find that by increasing the number of circles and increasing the speed, it really didn't get you where you wanted to go. You wanted to do more circles, but you wanted to do them at the slower speed. So that's where the other parameter in the variables file comes in. So let me go back and reset this to where we had it before. So if we go into material database, and let me just set this back to, we had 3 before there, save and exit, and I'm just going to go back. And the other way to get it to recognize that change, if you go back to your geometry tab, you can just do something like just draw a point and then do an undo, and that again resets everything in the WARDCam toolpath. And then we'll just go ahead and do our toolpath again here. Let me just check, double check here. So we do CNC. And reload. So we're back to basically where we were before. So, okay, say, all right, that's the speed I want to do a map, but I want more circles, but I don't want to change that speed. On this last step here, you go into options, edit variables, and scroll over to your Waterjet tab. And then you scroll down, there's a field for extra pierce turns. So if you change this number, it will change the number of circles, but, oh, sorry, I haven't been, oh my goodness. Just saw that. Sorry about that, people. Let's try this. All right, so sorry we're going through all that with my screen pause. So basically what you'll see here now is that, let me go ahead and make the CNC file. We'll go ahead and overwrite this. So now we've got the extra pierce turns, but it's doing it at the slower feed rate of the initial piercing. So since I was not sharing the right screen before, let me just review where I was going here. So database, material database, and go into the other area, and you've got your circular lead turns. So if you do change this number, just be sure that you either go back to the parts area and change your machine setting, and then that will reset everything, or you can go back to your geometry screen and just draw something and undo it, and that will also reset the tool path. So the other thing that you have to be careful about if you change and you want it to actually be recognized is if you change your tool diameter. So let me just go back into my shapes library, and we'll pick the rectangle here, and I'm just going to go ahead and let's say we want to do this with the 1440 nozzle combination. So we're going to offset our tool path by 20 thou to compensate for that 40 thou tool diameter. So if I go ahead and I'm going to put my tool path on here, and I'm just going to move my 0 point so it's right at the corner so we can see the tool offset here. So because we've got our 40 thou tool diameter, you'll see we have 20 thou tool offset. Now, if you decide that, hey, for whatever reason, I want to change that tool diameter, you can go into your machine database. And up here, we've got our nozzle diameter. So right now it's 40, so I can change that to say 0.45. And this max nozzle diameter, typically set that to about 2 thou bigger than that. And we can save and exit. Now, if I go ahead and click on CNC button again, then brings this up, reload it, we'll see we're still at the 20 thou offset. So similar to the number of turns on the circular piercing, if we want WARDCam to actually recognize that, we need to either pick a different machine and toggle back, or go back to our geometry screen and again, just draw something, undo it, and then re-add your tool path. So I'll put my tool path on here again, create my CNC file. And then when this reloads, we'll see now let me just change actually my 0 point because that goes to the perimeter of the part. So we put that right on the corner of the part. We will see now that our offset is half of the 0.45. So those are a couple things that if you change them, you just have to make sure that you either change machine and then go back, or go to that geometry screen and draw something and undo it and then re-add your tool path. Let me open up a file, just review etching and points, how to program point pierces and things like that. So this part here, I'm just gonna clean this up. I've got my trim tools here. I can trim these things up, can draw a line and connect. And I'm just gonna go ahead and delete this stuff up here. So if I wanted to just pierce this really small hole, I can use my point function, and I can, when that little blue circle shows up there, I can just left click, add a point at the center of that circle, and we'll pick up that for pierce. We're gonna cut this here, and we're gonna etch these numbers up here. So once you go over to your parts area, over here on the right, we can choose things like point functions or open contour cutting. So if we wanna cut this slit here, if I choose open contour cutting, I can just click at the end of the line that I want to start at, and it puts that on there. Now you note that I put a little bit of a line here, and the reason I did that is normally on a open contour cut like that, if it's a straight line, we're not going to apply any ramping. That is, if the material file says to cut this at 50 inches a minute, it's gonna pierce and instantly try to go 50 inches a minute. So it might not actually start cutting through for small bit before the stream starts getting through the material. So one way to force it to do ramping on a geometry like this is just to draw a very short, can just be a few thousandths of an inch long line, and then WARDCam will see that and it'll ramp and cut this slower and then speed up as it goes through there. So to kind of show that, what I'll do here momentarily is just go ahead and I'm just going to delete these lines so we can see what it's like without those lines in there. And I'm just going to add the open contour cut for right now. And we'll just step through here and do the CNC file quick. So you'll see it's going to cut that line, and given the thickness, it's wanting to cut it at 225 inches a minute, and it's going to try to get to that right away. So to avoid that, again, we can come back here and I can put those little line segments back on there. And if we do our open contour cut again, click on the end, hit next, and we're just going to do that geometry for right now. So now we'll see. We'll go ahead and reload that. That's going to start, and then it's going to ramp up, actually ramps down for that first little corner, and then it's going to ramp up to full speed and then start ramping down as it gets to the end of that line again. So that can help you a bit on geometries like that. The other thing on this part would be etching. So I can use the marking command here. If I activate this tool, I can just left click and add my marking contours to that geometry. And your parameters for your marking are under your material database. If you go to database and then material database and go back to the marking tab with the advanced button turned on, you can tell it the feed rate that you want to do for that marking, if you want to have any sort of a delay when the water and or abrasive first turned on, and then whether you want to use the abrasive for the marking and whether you want to do low pressure marking or not. So if I leave the abrasive on and we do this, we'll just, again, just do this portion of it for right now. So here we see we've got a command at the top here that tells the pump to go into low pressure. There's a delay for it to get to low pressure. And then we've got water on, delay, abrasive on, half-second delay, and then does the marking at that 60 inches a minute. If you decide you don't want to do the abrasive with the marking, we can go back into our material database, go back to the marking tab, turn off the abrasive button, and if you want to minimize your delay at that point to reduce any little divot there, you can set that point dwell to 0 and make this file again. So now we'll see we've got the water on. There's still half-second delay, which again, you can change that in your variables file, and then does it at 60 inches a minute for the marking. And then the other thing in here is if you are just wanting to pierce a point, over on the right, we have the point functions options. So we can expand this and choose to do an abrasive pierce. And when I hover close to a point and I left click, then I'll add that to my cut sequence here. And the delay for this pierce point is in the material file. And if we go into the other area, that's this delay here. So if you need to give yourself a little bit more time, we'll set it to 2 seconds. And we'll take a look at what that file is going to look like. So we've got the etching, and then it's going to go over, it's going to go to high pressure. And then that's that open contour cut we did, and then it's going to wrap it over for the pierce point, turns water and abrasive on, and then we have a 2-second delay, and then the water and the abrasive off. So that's where you can control that. And then finally we can do a stop. Oh, here we have a point out here where you can go to this area over here, choose stop, and put that in there. So the cutting head would go over to that location, stop, and then you can hit continue for it to continue on. Now, because of a 1440 nozzle combination selected right now, when I've been going to this toolpath area, it's not showing the rest of the geometry here because it's looking at this gap here, and the gap is smaller than the tool diameter that I've given it. So if I switch to a smaller nozzle orifice combination like a 1030, that should be small enough, and I hit next, and then you'll see now that we can get through those areas there because the gap is wider than our kerf width. And then if I want to put my Toolpaths on here, I can click Auto. Now there's a parameter in the material file that can help you force your lead-ins away from certain geometries, which I'll show you here on actually a different file, shows a little bit better. Let's see, pick up this file here. So if I go ahead and we'll just go with that for right now, click on Auto. So depending on the geometries, you might find that maybe leads are getting too close to other areas of the part. And on the, again, in your material, turn on your advanced button, go over to the other tab. We have this dB material blowout distance, which is normally set to 0 by default. And let me just re-add my toolpath with that on there. There might be situations where the pierce point is getting too close to other geometries in the part, and that dB material blowout distance can kind of help you move those leads away from other things. The primary idea behind this blowout distance is if you're cutting a composite material like a carbon fiber and you're starting to get some delamination around your pierce points, you can basically tell it to make sure that it keeps your pierce points a certain distance away from any other geometries. So if I set it to a number like, say, 60 thou, and I hit on auto again, you see that these leads are going to move a bit. So you can adjust that so your lead in is more in the center of the geometry. Now, if you make that number too big, if I make it, say, depending on the geometry, it'll get to a point where it's not going to be able to put a lead on there. So now that blowout distance I gave it was too big, so it's not able to put a lead on that part. If you try and manually put it, it'll give you that error there. So you just need to adjust that blowout distance so it's something that's going to fit on the geometries that you have. Let's see if 80 thou works on this one, for example. So that's the infamous dB material blowout distance that may have been wondering about. And then I want to run through how to program a part to cut on a fixture. Let me just pull up a little video here. So sometimes you might get a situation where you just need to cut the outside of a part, or you want to cut some slots in a part. You don't need to cut the outside. You'll want to have a fixture on your table. So you normally start off with a piece of material like this that you can clamp down, and then you can use the Waterjet to trim out an L fixture, and then you can put your part in the corner of that fixture and then cut out whatever details you need to out of the part. So that's basically the concept of what I was going to show you here. So let me open this one here. So there's a couple ways of doing this. What I'm showing up here would basically be the blanket material that we're going to be cutting this part out of, and we're just basically going to be cutting around this area here, stopping here, and then just using the raw edge for here, and then we'll also be cutting out the holes in the slots. So one way of doing this would be, because WARDCam does not apply any tool offset to open geometries, if you were going to do it kind of like the old-fashioned way we used to teach, you would offset lines to account for your stream diameter. So that's why this line is offset from our actual parts. This would be half of our stream diameter that we've offset this line. And then I've also put a little jog here to, again, ramp like I was showing in that previous example. And you would so spend some time in CAD doing your offsets to offset all those lines appropriately. And then you would come over to this area here and you'd use the open contour cutting command, and you could click on that, and that would give you basically that cut there. So that's certainly one way to do it. And then you would come over to here and you could do your leads for the inside of the part. So you can just draw a box around there, put those leads on there. You can reorder your cut sequence, bring this down, and then from there, create your CNC file, hitting our next button. And the key thing is when you do this, you want to make sure that your 0 point is actually at the corner of your part or the center of this relief cutout, so that the part is accurately positioned on the fixture. So if I click here, puts that 0 point right on the corner of the fixture, and then create our CNC file and go from there. So that's one way of doing it. It takes a little bit of CAD work as far as doing the offsetting of the lines. Another way to do it is actually to, let me just go back to my geometry area here, is you've got your actual part geometry here, you've got your fixture geometry, and if we tell WARDCam that we're cutting with a 5-axis machine, even though we're doing vertical cuts here, you can tell it to do a portion of a cut with the Bevel command. So if I go into my machine database, even though I might not have a 5-axis machine, I can toggle on this 5-axis button and go over to my toolpath area. So first I add my leads on the part, and it will also put a lead on the outside, because the only way to add a bevel cut to a cut is to have a toolpath on it, which we're going to delete later. And then since I've told it that it's a 5-axis machine, we now have the bevels tool available down here. So if I activate this tool, I can just tell it that my bevel angle is 0. It's going to be a vertical cut. Doesn't matter what you put in for the bevel height. Doesn't matter in this case what we're doing. And then you click where you want to start the cut, and then where you want to end the cut, and then which portion of the geometry you want to cut, which in this case would be the side here. So I just left click, and that will lock that toolpath in on that portion of the cut. Got a short little lead out there, which I could change that length if I needed to. And then we delete the cut that's going around the entire outside. So over here on the right, I've got my cut sequence. So this cut here, we're not actually going to do. So I'm just going to delete that. And then we've got our other cuts on here. So once we've got that, then we can go ahead and hit the next button. And actually, I've got these other cuts on here. Let me go back and let me delete these ones here because we don't want this part. So we'll just delete those. And you can also hold down your control key and select multiple cuts. So if I want to delete all of these ones here from that old part, I'll just delete that. And so we go to our post screen, and again, we want to set our 0, point at the corner of the part. So you just want to zoom in, make sure you put it right at the corner or the center of that hole there. And then if we make our CNC file, go ahead and save that. And we've got our cuts. And then what you'll see when we get down towards that outside geometry is, since we told it that it was a bevel cut, even though it's vertical, you'll see that it starts putting in these C's. Now, even if you have a 2D machine, our controller will just ignore these C's and just run it as if it's a 2D part, so you don't have to be concerned about having those in your file. And just thought it might be fun just to do a little cut on one of our machines out at the out on the floor. So let me just minimize this, and so this is a view of one of our 2x4 machines that we have here. So just wanted to show that even though those C coordinates are in there, this machine, which is a 2D machine, is just gonna ignore those things. So let me just check and make sure that nobody's on any of the other machines that we've got high pressure running to. Actually, I closed off the hand valves earlier, but just want to make sure nobody opened anything up there. So nobody on either of those machines. So this controller here, I can go ahead and load that program that we just made. And let's see here. So that's this one here that we made at 1232. Open that up. And so there's the part, and I'm just going to minimize this for right now. So there's our cutting head. So if I want to, I can also turn the pump on. Don't know if we'll actually be able to see the stream when it does this. Give it a couple moments for it to ramp up to power. If I want to, I can switch to high pressure. Might be able to see the stream a little bit more. I can kind of see the material moving and shapes being cut out there. So this here on the left portion of the screen is our newer move controller that we use on our A-series machines. So now it gets to that outside cut. And again, even though it's got the C's in there for rotation, if it were a 5-axis machine, since it's 2D, it's just going to ignore those and cut it as a 2D cut. So that's a little bit of an easier way to program a part where you've got open contour cuts. Just tell the machine that it's a 5-axis machine, and then set that angle for the cut to 0, and then makes it quite a bit easier. So we'll go ahead and turn that off. So another question that often comes up is how to do command line cutting in WARDCam. And again, it's one of those things that takes a little bit of work in CAD to make it happen. So there's a couple different ways of doing it. So if we wanted to cut, say, 9 of these squares, 12 by 12, one way of doing it is drawing your squares to 12 by 12 and then arraying them out and putting in your gap between your parts of 30 or 40 thou, depending on your stream diameter. And then drawing lines down the middle between those parts, which is going to end up being your toolpath. And again, as open contour cut, I would put a little short little jog at the beginning of the end so that it ramps up and down at the beginning and the end of each cut. So you put those between each of those cuts there. And then for the outside, you can just basically draw a rectangle from corner to corner and then delete the other 9 smaller rectangles, and then can join all your other lines together. And then with that, you'll be able to use the open contour cut command and add your toolpath with that. So that would give you 5 separate cuts, depending on the sequence that you did it at, up, down, across, and then a 5th cut to go around the outside. And if you want to save yourself a pierce, slightly different way to do this would be same basic technique as far as drawing it up with the offsets. But on one of these squares, you just leave a small gap here, and then again, a little jog out. So make sure it slows down as it gets towards the end of the cut there. And then you can do this outside as one cut along with the last, in this case, vertical cut. So it'll come up the vertical and then go around the outside. So if we actually do that, so we'll open up this one. All right. So I'm just going to go ahead and delete these ones here. Actually, we'll get rid of that, show you just the 2 different ways that we could do it. So if we do it the first one, see we've got the 4 individual open contour cuts. So I can choose what end I want to pierce at. So I can pierce here for that, pierce here, pierce. And then for the outside cut, we go to our toolpath area, of course, and then put our lead on there where we want it. So 5 separate cuts. Or if we do it the other way, zoom out here a little bit and do it this one. So now all of these are open contours, and you just have to choose things in the correct sequence. And let's see, looks like these got a little bit disjointed here because these should have been joined together. Let's see, did I not join those together? Yeah, so let me just escape here. Sorry, we'll just explode this here. And I am going to join some lines together here. So basically need to join those lines together as one line. And then I'll join those together. And let's see, join those together. Let's join. Let's see, so now, and then finally we will join these. So let's go ahead and see if that worked. Reopen that. All right, open contour cuts. All right, yeah, guess I messed up that drawing there. Let me open up the other version. I was playing with that one earlier. All right, so got that cut. And then whichever sequence that you want to do these other cuts at. So as I hover near the end of that, could do that one, and then do this one, and then click down here, and then it'll do that as the outside. So it's, again, takes a little bit of CAD work, but something that can be done. Of course, you don't want to be a little bit careful that parts don't tip up on you, and especially if it's an abrasive application, that you don't break a nozzle. And speaking of that, there is the option in WARDCam, if you have Programmable Z, to have the cutting head move up and down between all of your cuts. So first of all, you can know whether you have Programmable Z or not on your machine on the controller. If you see that you've got Z motor here, then you've probably got Programmable Z. And then if you do something like come into your move panel and tell the Z to move incrementally in a direction, then that would be a good indication that you've got Programmable Z on your machine. So if that's the case, then let me open up a different file here. All right, so if we want to lift between each of these cuts, we can just go ahead and, again, whatever material, doesn't really matter, hit on auto. And in the last step in your process here, if you go up into options, edit variables, and go to your height sensors tab, you can basically use this to tell it to move up and down between cuts. I'm going to turn off my scroll lock key so we don't see all the different fields that we've got here. So again, I'll go back to my on-screen keyboard and turn off my scroll lock key. So edit variables, height sensors. So the default values that are in here would be if you had one of our 2D height sensors. So this is what it would use to move up and down. But if you don't have the height sensor and you just want to use your Programmable Z to move up and down, this first height sensor thing, you can either just blank this out or you can put a semicolon in front of that, which makes it a comment instead of a, so that'll just ignore that. So height sensor down, you can just do G00Z0, so that'll tell the cutting head to go back down to where it started the program from. And then your height sensor up can be G00Z, and then the brackets and the 0, it pulls from this value here to tell it to how much to lift by. So in this case, it's going to lift by 1 inch between cuts. You can also tell it to lift at the end of the program, because normally WARDCam wouldn't do that. So if at the end of the program you want the cutting head to lift up an amount so you can then jog out of the way and hopefully avoid any clamps, if you turn this on, then it'll use this field down here at the end of the program to lift. So if you want to lift by a different value, you can tell it to lift by 2 inches at the end of the program. And so now if we go ahead and make this file, so we'll see that, actually, I'm sorry, one step I missed there. Of course, edit variables, height sensor, you actually have to tell it that you want to use height sensor. So turn that on. And then reload this. So it'll jog up at the beginning of the program, wrap it over, and then go down, do the cut, and then so it's going to lift by 1 inch between each of those cuts. And then at the end of the program, it's going to lift by the 2 inches that I told it to. So that can come in handy if you do get parts and things that are tipping up. So a couple of little things here. Let's see, open up this file here. One of the common calls that I might get is somebody's working with a file and they say it crashes WARDCam. File like this, we go along, everything looks good, everything's green, hit my next button, and it's gonna end up crashing at this point. And oftentimes this is going to happen because there's geometries that are overlapping, and then when WARDCam is trying to add the toolpath, it gets confused as far as what's an inside and what's an outside cut. So if you are getting a program like that that's causing issues like that, you just want to look at it and see if there's anywhere that you've got geometries that are overlapping. So on this file here, if we zoom in, we see we've got the A and the I that are overlapping, and that's what ends up causing it to crash. So I've got my select tool active, and don't want that, I want that. And then I can use my move tool, can turn my ortho button on if I want to make sure that it just moves straight across there. And now everything should be good. And I'll switch back to aluminum. And so on and so on. So one other thing that you have to be careful of if you get any drawing file from customers that they've drawn all their geometry in the same Z-plane, because WARDCam can pick up on differences in the Z-plane, and that can cause crashes depending on where the geometries are drawn. So for example, so a part like this we look at and it looks fine, hit our next button, and we go through and everything's good. Hit our next button, hit our CNC file, and save. Now we've got our initial up there that we put in, and then it rapids, and you see on this rapid move it's actually wants to go down to Z of -1, which would want to, of course, drive your nozzle through the material, which would be bad. So this, as I said, usually happens if somebody draws geometries that are not in the same plane. So if we look at it in CAD, of course, from the top view looks fine, but if we switch to side view, then we'll see this is the outside, and then here's our circle in the middle. So just have to be careful of that if you do get drawings from customers, make sure that everything's in the same Z plane. And then final thing, if you don't already have the update or aren't aware of it, we do have costing now available on their report. So if I click on the report button here, and I'll just create this, you can optionally turn this costing information on or off. So you can plug in information like what you paid for your machine and what you're paying for abrasive and consumable cost and life, and print this information up. And if you go into options, edit variables, and go onto the machine tab, or the reports tab, first of all, the new version, you've got the option to accept the waiver, and then you can choose to print that cost information. And you can also choose to be prompted whether you want to print the cost information or not on the report. So if you're going to be sending one version of the report out to the shop and you don't necessarily want that information floating around the shop, you can turn this on and be prompted to print that. You can choose to just use simple fixed costs and simple other consumable costs, or if you go onto the machines tab, then you've got the more detailed breakdown of all the different costs that are going into calculating the fixed and consumable costs that are printed on the reports. So how many hours per year you want to run it, and what you paid for the machine, and how much you want to allocate for your operator and overhead and profit, and etc. Non-productive time. So if you want to allow for programming and loading and offloading and packaging and things like that, if you want to charge a different rate for that non-productive time, you can. What you're paying for nozzles and expected life of nozzles and orifices and seals, and all those things can be put in there. And then if you're just using the simple version, you don't want to get into all the details of that. This is the number that's going to use for the simple other. And then there's also a fixed cost simple up there that you can also use, which was, I forget where it was now, but it's up here somewhere. Simple, there is fixed cost, simple, fixed cost. So if we go to create the report now, and it'll come up with this box here. So if I want to print the information on the report, I can just leave that as 1. And there it is. If I do it and I don't want to print that, then I can just change that to 0. And does it with the estimated time, but no costing information. So that covers what I wanted to go through today. Sorry that we had the issue early on there with the not sharing my screen. Before we post this to the web, I'm gonna go ahead and re-record the first 10 minutes and put that on there so you guys can all see what was going on there. But appreciate your patience, and everybody have a great weekend. Thanks.